Okay, picture the Amazon rainforest for a second. Just massive, right? Full of life, teeming with secrets.
Absolutely vast.
Now, imagine finding something completely unexpected there, something from, well, a long time ago, like dinosaur time.
Yeah, it's kind of wild to think about. That same ground millions of years back had giant creatures walking on it, and one of those giants is what we're focusing on today, Amazonsaurus.
Exactly. Welcome to the deep dive. We're going straight into Amazonsaurus, this sauropod from the early Cretaceous found in Brazil.
Uh-huh.
And if you want the key info on this amazing creature, without getting bogged down in overly technical stuff, this is the place. We're using excerpts from the actual scientific paper.
Right. So our mission here is pretty straightforward. Pull out the essential facts about Amazonsaurus. What was it like? When did it live? How does it fit into the whole dinosaur picture?
And what does its discovery actually tell us about that period, the early Cretaceous?
Exactly.
Okay, let's start with the name, Amazonsaurus. It sounds cool, but how do we say it properly?
Good question. It's A-M-U-S-A-N-S-O-R.
A-M-O-D-A-R-A's. Got it.
And the name itself, well, it's pretty literal. It just means Amazon lizard.
Makes sense. Named right after where they found it.
Precisely. A direct link to the region.
Which is kind of unusual, right? Finding dinosaur bones in the Amazon.
It is quite rare, yeah. The specific species is Amazonsaurus marinhensis. That second name, marinhensis, refers to Maranham, the state in Brazil where it was discovered.
Ah,
And what's really significant is that, believe it or not, this was the first named dinosaur genus ever found in the entire Amazon basin.
wow, the first one. That's huge. So who are the paleontologists behind this?
It was a team effort. Two Brazilian paleontologists, Ismar de Souza Carvalho and Leonardo de Santos Sevilla, worked with an Argentinian colleague, Leonardo Salgado.
Okay,
They're the ones who formally described it and gave it its name back in 2003.
2003. Okay, so we know where, we know who. Let's get a picture of this dinosaur. What did Amazonsaurus actually look like back in the early Cretaceous?
Right, so we're talking early Cretaceous period. And Amazonsaurus belongs to a group called the Diplodocid sauropods.
Diplodocoids.
Yeah,
Those are the classic long necks, right?
exactly. Think big four-legged plant eaters, really long neck, and usually that distinctive long whip-like tail. That's the basic body plan.
The quintessential image of a gentle giant, maybe? Munching on ferns?
Probably something like that, yeah. Now, some diplodocoids got absolutely enormous later on, huge. But Amazonsaurus seems to have been, let's say, more moderately sized for a sauropod.
Okay, so not the biggest of the big.
Probably not. The estimate is maybe around 12 meters. That's about 40 feet long. Still pretty big, mind you.
Definitely. 40 feet is not small. Any idea how heavy it might have been?
Well, there's an estimate from Gregory S. Paul back in 2010. He figured around 5,000 kilograms.
5 tons. Okay, that's substantial. You wouldn't want it stepping on your foot.
No, definitely not.
So what did they actually find? Was it like a whole skeleton lying there?
Oh, if only. Paleontology is rarely that easy. No, it was quite fragmentary, actually. They found some vertebrae, bones from the spine, from the back and the tail, a few ribs, and some pieces of the pelvis, the hip bones.
Not a lot to go on, maybe?
It might not sound like much, but it's incredibly valuable information, especially because from that particular rock layer, the Adipakuru Formation in Maran, these are the only dinosaur fossils that scientists have been able confidently identify down to the genus level.
Wow. So these few bones are our main window into the dinosaurs of that specific place and time.
Pretty much, yeah. It highlights how much we still don't know.
Tell us a bit more about that formation, the Adipakuru. What sort of place was it when Amazonsaurus lived there?
Okay, so the Adipakuru Formation, geologically speaking, it dates to the Aptian and Albian epochs. That's in the early Cretaceous.
Which is roughly when?
We're looking at about 125 million to maybe 100 million years ago.
Okay.
And the rocks themselves, where the fossils were embedded, they look like floodplain deposits. So think of a wide, flat area near rivers, probably close to a river delta, prone to flooding.
So lots of water, probably lots of vegetation.
Exactly. The kind of environment that could support a large herbivore like Amazonsaurus, lush plant life would have been crucial.
Right. Okay, so we have the time, the place, the basic look. Let's talk family tree. You said it's a diplodocoid. Where does it slot into that group?
Well, the key clue comes from those tail vertebrae I mentioned. They have these really tall, bony projections sticking upwards called neural spines.
Neural spines, okay.
And the shape and size of those spines are very characteristic of diplodocoids. It's one of the main reasons we can confidently place it in that superfamily. They helped anchor big tail muscles.
So that feature locks it into the group. but placing it precisely within that group.
That's where it gets a bit tricky, yeah. Because the remains are so incomplete, figuring out its exact relationships to other diplodocoids, like Diplodocus itself or others, is challenging. It's like having only a few pieces of a big jigsaw puzzle.
I can imagine. But scientists must have some ideas, right? Based on the clues they do have.
Oh, absolutely. There are features in the vertebrae that hint. Well, they suggest Amazonsaurus might be what we call a basal member, sort of an earlier branch on the diplodocoid family tree.
Basal, meaning more primitive in evolutionary terms.
Kind of, yeah.
Yeah.
Or perhaps representing a lineage that branched off earlier and just survived longer than some others. A late survivor of an older group.
Interesting. Was there any specific analysis done on this?
Yes, there was. Salgado and his colleagues did a cladistic analysis back in 2004. Cladistics is basically how scientists map out evolutionary relationships, like building that family tree based on shared features.
Right.
And their analysis suggested Amazonsaurus was, let's see, more advanced or derived than another group called Rhybocosaurids,
Okay.
but still more basal, more primitive than the Dichrosaurids and the classic Diplodocids. So it fits somewhere in the middle to lower branches of that diplodocoid tree.
So it's like finding an evolutionary stepping stone almost.
Right.
It tells us something about how that whole group evolved.
Exactly. Each discovery like this adds another piece to that puzzle.
What does finding Amazonsaurus there tell us about the bigger picture? Like the whole dinosaur world in South America and Africa back then?
That's a really important aspect. Remember, in the early Cretaceous, South America and Africa were still connected, part of the giant southern continent Gondwana.
Right, Gondwana.
And when we look at fossils from that time, we see other basal diplodocoids, similar perhaps to Amazonsaurus, in both South America and Africa.
So they were widespread across that connected landmass.
Seems like it. And they shared that world with other sauropods, the titanosaurs, who would later become dominant, and also some pretty fearsome predators. Big theropods like Carcharodontosaurids, think giant shark-toothed reptiles, and also spinosaurids, those crocodile-snouted fish eaters.
Wow, quite a crowd. A very different set of players than what we see later on, isn't it?
Totally different. Fast forward to the late Cretaceous, and the landscape has changed dramatically. The diplodocoids, mostly gone.
Vanished.
Pretty much vanished from the record, yeah. The titanosaurs really took over as the main large herbivores, and the dominant predators changed too. Those earlier big theropods were largely replaced by a group called abelisaurids.
Abelisaurids. They're the ones with the short arms and sometimes weird horns, right?
That's them. Often smaller than the earlier giants, but still very effective predators. The source material even mentions Angulatitan, a titanosaur found in Angola from the late Cretaceous, highlighting that titanosaur takeover.
It really shows that ebb and flow of life, doesn't it?
That's-
Whole dynasties of dinosaurs rising and falling over millions of years.
It's a constant process of change, yeah, driven by environment, competition, evolution. It's fascinating.
Okay, so let's wrap this up. If we boil it down, what are the absolute key takeaways about Amazonsaurus from our deep dive?
Well, first, it's an early Cretaceous sauropod, a diplodocoid specifically. Its discovery location is huge, the Amazon basin, making it the first named genus from there.
That first discovery aspect is really something.
Definitely. Physically, think large, four-legged plant eater, maybe 12 meters long. And while the fossils are fragmentary, just vertebrae, ribs, pelvis bits, they're enough to classify it as a relatively basal diplodocoid.
Giving us clues about the early evolution and spread of these long-necked giants.
Exactly. It paints a picture of the dinosaur fauna in that part of Gondwana before the big changes later in the Cretaceous.
And it's just mind-boggling to think that this single find, these few bones, opened up a whole new chapter for paleontology in the Amazon. It just screams, what else is down there?
It really does. The potential for discovery in that region must be immense, though challenging to access.
Which leads to a final thought, maybe. You mentioned Amazonsaurus might be a late survivor of an older branch.
Uh-huh.
So thinking about that, what other kinds of evolutionary stories might still be locked away in the Amazon's fossil record? If we found more, what could it tell us about why some groups survived and others didn't during that really crucial time in the early Cretaceous?
That's the million-dollar question, isn't it? What pressures were at play? How did ecosystems shift? Finding more fossils there could radically change our understanding of that whole period, not just for dinosaurs, but for the evolution of life on Earth. There's likely so much more waiting to be discovered.